In this table assignment, we're supposed to figure out how heavy this thing is. How much does it weigh? And let's step through how we will do that. Here's the sketch that we got to begin with. And now here is my assembly drawing. Yours might look a little different. That's totally fine. This happens to be what mine look like. And I put my item numbers in this particular order. In the way I did my drawing, I decided I wanted the plate, that 3/8 plate that is the top of the table, to be item 1. And you'll see it there in my bill of material and my item number bubble. And they tell us that it's 48 by 36 inches. All right, here are the part numbers that we're using for this class. This is where you're getting the part numbers that you're putting in your bill of material. And you get that from at the beginning of the Moodle class. Let's, oh yes, and I wanted to point out that I have filled in the weights for the steel parts, and you can just go ahead and use those weights there. I got them from the Far West Steel catalog, so you can always refer to that steel catalog also. Let's zoom in on the plate, the 3/8 plate, and here's that portion of the part number list where I've entered the weight from the Far West catalog. Let's look at the columns one by one. That thing that says UOM stands for unit of measure. And it says for the plate, the unit of measure is SF, which stands for square feet. Okay? And the weight is in pounds. In case you're wondering, are these grams or pounds? They're pounds. All right. And for this 3/8 plate, the weight is 15.314 pounds per square foot, because they tell us the unit of measure is square feet. So that's how much it weighs per square foot. And our plate is 48 by 36. We need to figure out how many feet that is. So there are 12 inches in a foot. 48 divided by 12 gives you 4, so it's 4 feet wide. 36 divided by 12, it's 3 feet high. So it's 4 feet by 3 feet. And if you say 4 times 3, that tells you there are 12 square feet. All right then. And we know that each of those square feet weighs this, 15.314. So 12 of those square feet times that weight. The square feet cancel out. So 12 square feet times blah, 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 pounds per square foot. The square feet cancel out, and we get a number. 12 times 15 point something equals 183.768 pounds. That's how much the tabletop weighs. So let's start writing these down. And you can certainly do this on a piece of scratch paper or in an Excel sheet or wherever you want to. I just wrote them on the slide here. So here's what the 3/8 plate weighs. All right, let's go on to the next part. In my particular drawing, I decided I wanted to make those legs item number 2. Those are those 3-inch square tubes. So there's item number 2. And there are 4 of them, aren't there? There are 4 legs. And how long are they? Well, the overall height of this table is 30 inches altogether. But there's a 3/8 plate that's part of that. So the legs which come up to the bottom side of the plate, are 29 5/8 long. So that's how I figured out what length to put in my bill of material. Over here in the size references, I wrote 29 5/8. Our shop person, like our sawyer, can use that to know how long to cut these legs. Okay? And then we'll go back to our part number list. There's our tube. And I know it doesn't say tube, it says HSS. That stands for Hollow Structural Section, which is AISC's fancy way of saying tube. And this thing is not pounds per square foot, this is pounds per linear foot. And this particular size of tube, it says, is 8.8 pounds per linear foot. All right. And our tube is 29 5/8, so we need to convert that to feet, don't we? 29 5/8 divided by 12 inches per foot tells us that each leg is 2.469 feet long, just under 2.5 feet long. And we have 4 of them, so each one of them is that long. Altogether, we have 9 7/8 total feet of square tubing that we have to account for. Here's our part number sheet with our weight. So we have a total of 9 7/8 feet of tube because we have 4 legs. And that 9 7/8 feet times 8.8 pounds per foot. The feet cancel out and we are left with pounds. We have 86.9 pounds of leg. All right, let's write that down. So item number 2 for my drawing. I'm just keeping track of the quantities. I don't need to do that when I'm doing this tallying, but I like to do that just to make sure I didn't forget to include it. Okay, so now we've got the weight of the tabletop and the weight of the 4 legs all together. Now let's go on to the angle iron frame. And in my drawing, I decided to make the long angle item number 3. It's 2.5 by 2.5 by 1/4 inch angle iron. And how long is that one? Well, I just went into my assembly view here and copied this view of the angle iron and put that copy in my detail sheet. So that way I'm guaranteed that that really is the length of that piece of angle. And then I dimensioned it and it turned out to be 41 inches long. And you'll notice, looking at the assembly view, there are 2 of those. Okay, so here's the part numbers for the angle. Again, that weight is a unit of measure of linear feet, and each linear foot of this angle weighs 4.1 pounds. So how many feet is that? 41 inches. 41 divided by 12, that's just under 3.5 feet. But we have 2 of them, so that length times 2 gives us a total of 6.833 total feet. All right, and that many feet times 4.1 pounds per foot, the feet cancel out, gives us just over 28 pounds for that big piece of angle. Now I'm going to write that in my list. Here it is, item 3, and I entered the weight right here. All right, on to item number 4. In my drawing, I made the short piece of angle in this picture frame shape my item number 4. And I copied it into my detail sheet and dimensioned it, and it turned out to be 29 inches long. And again, notice there are 2 of those. There's 1 on each side. So it's the same size of angle, 2.5 by 2.5 by 1/4. It still is 4.1 pounds per foot. So how many feet do we have of the short one? We have 29 divided by 12 is just under 2.5 feet, but we have 2 of them. So just under 2.5 feet times 2, we have 4.833 feet total for the short angles. And so 4.833 times 4.1 pounds per foot, the feet cancel out, and we have 19.817 pounds for the short angles. And so I've added that to my list where I'm keeping track of the weight here. And then finally, my item number 5 is that cross brace that stabilizes those legs. So that's item number 5. I copied one from my assembly view into my detail sheet and dimensioned it, and length to nose to nose, the very longest that overall length was 37.670. And notice you have to include the entire length, because somebody in the saw shop is going to have to figure out, okay, how much steel am I going to need here? So that's how much. And again, notice there are two of those. That is a smaller size of angle. Here it is, 1.5 by 1.5 by 3/16, and it weighs 1.8 pounds per foot. How many feet do we have? 37.67 divided by 12, 3.139 feet per brace. We have 2 braces, so we have a total of 6.278 feet for the braces. And that many feet times 1.8 pounds per foot gives us 11.301 pounds for the braces. So now we can add that to our list, which I have done here. All right, so now I've figured out the weights for all of these parts. And now I want to add them up because I'm supposed to find out what is the total weight of all these pieces. So I get out my calculator and I add them up, and I come out with 329.803. Would it be reasonable for me to write 0.03 of a pound in my weight? No, not really, because this is a pretty rough estimate. So I'm going to round off and just say I've got 329.8 pounds for my table. And so I wrote a note on the bottom of my drawing. Note, calculated weight is 329.8 pounds. I could have put that note up above my bill of material instead if I wanted to. I typically put notes in the lower left corner. So, how accurate is this weight? I know we just rounded off, but in addition to that, how accurate is it? Well, first of all, remember that all of our dimensions have a tolerance. In this sheet, I've said plus or minus 30 thousandths, which is about a 32nd of an inch. So all of these lengths can vary. All of those angles can vary by 1/2 degree. So there's some squishiness. Then we're welding this thing. I've sort of indicated the welds with red lines here. So there's a bunch of weld material, welding rod, that got added. So that makes it heavier than we calculated. Then on the other hand, all these angles are cut. They have not chamfered ends, but they're mitered. The ends are mitered. All right, so that deducts some weight. And here, just to think about it, I'm saying, well, the picture frame angles are all mitered 45 degrees, so if you put them all end to end, what would you have? Notice you would not have a total 41, 41, 29, 29. You'd have something less than that. And then here at the bottom, I was imagining what would happen if I put those braces end to end. So that's going to subtract some weight. And by the way, later on this term, we're going to revise this table and drill some bolt holes in it. So those holes are going to deduct a little bit of weight. So is that an accurate weight? No, it's not. It's approximate, and that's totally fine because we just want a rough idea. Maybe we want to lift this with a forklift, and we want to know, well, or you know, an overhead crane thingy. We want to know, well, what capacity of forklift or crane do we need? Is this thing 5,000 pounds? Is it 50 pounds? What have we got here? So we have approximated the weight, and I came up with this number. Your number might be a little bit different. That's totally fine, but you want to be in this ballpark here somewhere. So there's the weight of our table.